All right, Valerie, you left before I could go over this problem with you, so I decided I'd try and make a video and see if I can send it to you instead. So the first thing I do when it says refer to these figures, we're looking for all the true statements. I know it's difficult for me to actually see these two triangles, so I like to draw them separately. So here's going to be the small one. This will be ADE. And we know that this is x degrees. And we know this is 2. We know this is 5. We don't know this length. And we have our large one. We know this is A, this is C, and this is B. This is 6. This is 15, not 10, because that whole length is 10 plus 5. And we know that this angle A is congruent to this angle A because they're the same angle. We don't know if we can prove these two triangles are similar, then we know that this will also be x degrees. But we don't know that yet. So let's check and see what we do know. Let's just go down the list here. Angle ACB, that's this one, ACB, is 180 minus x. Well, I don't think that's going to be true because we know if this is going to be true, then this will be x, not 180 minus x. That would be this angle and this angle put together. So we know this one's not true. Let's take a look at angle ACB is x degrees. Well, we know if they are similar, then that will be true. And we could actually check and see they are similar if they are proportional. Oh, I can see right here they are because 5 times 3 gives us 15 and 2 times 3 gives us 6. I could also write my proportion out, but I know that they are going to be proportional. We can go ahead and do it. Let's do 5 to 15. That equals 1/3. And we can do 2 to 6. That equals 1/3. So we know that their corresponding sides are proportional, which means that they must have the same angle measure. So we know this one's true. Triangle ACB is similar to triangle ADE. ADE, ACB, yes, we just proved that one because they are proportional, or I could say dilate this by a scale factor of 3 and from point A, and it will dilate, ding, and land right on top of it. And the very last, I think that's the last one. Let's see, is there another one down there? Oh, there is another one. Okay. So AD equals 1/3 AC. So side AD right here is equal to 1/3. Well, I already know that they have a proportion of 1/3 because they're similar. So I know whatever this is, this side could be like 10. This side would have to be 30 because it's being multiplied by 1/3. So AD is 1/3 of AC because no matter what this is, we could even just call this like, let's call this Y, and this would have to be 3Y because it's being multiplied by 3. And the very last one, let's see, AD equals 1/2 of DC. AD, DC. So we can't look at this one on here. We have to look at it on here. And we're saying like, we'll do an easy one. We'll say this is 1. If that's true, then that's 1. Then this side here, if this is 1, then this side would have to be 3, which makes this portion of it 2. So yeah, I would say this one is true as well because AD has to be exactly 1/2 of DC. Just like, scroll this up, just like EB is twice as big as AE because that piece there is included when we look at it as 3. So the ones that are correct would be B, C, D, and E. I hope this video was helpful. I'm going to send it in an email to you. Hopefully you'll be able to see it.